Class 12, Chapter number 7, Wave Optics, very short answer questions. First question, what does the formation of shadows tell us about the propagation of light? Answer, shadows show that light travels in a straight line, which is also called as rectilinear propagation. State the laws of reflection. Answer, first, incident ray, reflected ray and normal to the surface lie in the same plane. Second, angle of incidence I is equal to angle of reflection R. What is the range of wavelengths of visible light? Answer, 400 nanometer violet to 700 nanometer red. What phenomena support wave nature of light? Answer, interference, diffraction and polarization support the wave nature of light. What is the refractive index of a medium? Answer, it is the ratio of the speed of light in vacuum to the speed of light in the medium. What happens to wavelength of light when it enters a denser medium? Answer, wavelength decreases because speed decreases but frequency remains constant. What are primary sources of light? Answer, sources that produce their own light. For example, sun, stars, flame, bulb, tube light. What are secondary sources of light? Answer, sources which do not produce light of their own but receive light from some other source. For example, moon, planets, etc. What path difference is introduced when light travels a distance d in a medium of refractive index n compared to the same distance in vacuum? Answer, path difference is equal to d into in bracket n minus 1. Define wavefront. State its type. Answer, a wavefront is the locus of all points of a medium to which wave reaches simultaneously such that all the points are in same phase, and their types are spherical, plane and cylindrical. What is a spherical wavefront? Answer, a spherical wavefront is a wavefront produced by a point source of light in which the wavefronts are spherical surfaces having the source at their center. What is a plane wavefront? Answer, a wavefront produced when a spherical wave travels far away from the source and becomes nearly flat. State Huygens principle. Answer, every point on a wavefront acts as a secondary source of light and emits secondary wavelets in all possible directions. The envelope formed by joining tangent to all the secondary wavelets gives the position of the new wavefront at that instant. The new secondary wavelets are effective in the forward direction only. Why does bending of light occur during refraction? Answer, because the speed of light changes when it enters a medium of different refractive index. What happens to frequency during refraction? Answer, frequency remains constant. What is unpolarized light? Answer, light whose electric field vibrates in all possible directions perpendicular to propagation. What is plane polarized light? Answer, light whose electric field vibrates only in one plane. What are polarizers? Answer, materials that allow only those light waves whose electric field vibrates along a particular direction. State Malu's law. Answer, statement, intensity of polarized light transmitted through an analyzer is directly proportional to the square of the cosine of the angle between the transmission axis of the analyzer and the plane of polarization of the incident light. Expression is I is equal to I naught into cos square theta, where I is the intensity of light transmitted through the analyzer, I naught is the intensity of the incident polarized light falling on the analyzer, and theta is the angle between the transmission axis of the analyzer and the plane of the polarization of the incident light. State Brewster's law. Answer, Refractive index of transparent medium is equal to the tangent of polarizing angle mu is equal to tan theta b, where theta b is the polarizing angle or Brewster's angle. Why is light considered a transverse wave? Answer: light shows the phenomenon of polarization. Only transverse waves can be polarized. Why does wavelength change during refraction? Answer: because speed changes while frequency remains constant. What do you observe when two polarizers are rotated? Answer: first, when the transmission axis of the two polarizers are parallel, maximum light intensity is transmitted. Second, as one polarizer is rotated, the transmitted intensity decreases gradually. Third, when the polarizers are perpendicular, no light is transmitted. And fourth, the intensity reduces according to cos square theta. What is interference of light? Answer: interference is the phenomenon of redistribution of light energy due to the superposition of two coherent light waves resulting in alternate bright and dark fringe, or the modification in the intensity of light produced by the superposition of two or more light waves is called interference of light. State the conditions for constructive interference. Answer: constructive interference occurs when phase difference is equal to 2n pi or path difference is equal to n into lambda, where n is the integer and lambda is the wavelength. State the conditions for destructive interference. Answer: destructive interference occurs when phase difference is equal to 2n minus 1 into pi or path difference is equal to n minus 1 half into lambda, where n is the integer. What is fringe width in interference? Give expression. Answer: distance between two successive bright or dark fringes is called fringe width, and the expression is W is equal to lambda into capital D divided by small d, where lambda is the wavelength, capital D is the distance between slits and the screen, and small d is the separation between slits. Why are interference fringes equally spaced? Answer: because path difference varies linearly with distance from the central fringe. What are coherent sources? Answer: sources emitting light waves of same frequency and constant phase difference are called coherent sources. Why independent sources of light cannot produce interference? Answer: because they do not maintain a constant phase difference, hence no stable interference pattern is formed. State the expression for the position of the nth bright fringe in Young's double slit experiment. Answer: the position of the nth bright fringe is given by yn is equal to n into lambda into capital D divided by small d, where n is the integer, lambda is the wavelength, capital D is the distance between slits and screen, and small d is the slit separation. State the condition for the position of the nth dark fringe in Young's double slit experiment. Answer: the position of the nth dark fringe is given by yn is equal to n minus 1 half into lambda into capital D divided by small d, where n is the integer, lambda is the wavelength, capital D is the distance between slits and screen, and small d is the slit separation. What is central bright fringe? Why is it bright? Answer: the central bright fringe is the bright band that appears exactly at the midpoint between the two slits in Young's double slit experiment. It is bright because the light waves coming from both slits travel equal distances to reach them center. Hence, the path difference is 0, which satisfies the condition for constructive interference producing maximum intensity. What happens if source intensities from two slits are unequal? Answer: if intensities of two sources are unequal, then intensity of light in interference pattern varies from maximum to minimum but not become zero. Therefore, dark fringes are not completely dark and contrast decreases. Thank you so much.